A warm welcome, dear students. So, it has been a long time since we met through the lectures. So, anyway, we will continue the discussion on thermodynamics. So, in the last session, we have discussed about the thermodynamic equilibrium, the four kinds of equilibrium: mechanical, thermal, chemical, and phase equilibrium. When all these things are satisfied, it is called a thermodynamic equilibrium. So today what we are going to learn is the process, a typical process which is quite useful in thermodynamics, known as quasi-static process. A quasi-static process or quasi-equilibrium process. So we have studied what a system is, what properties are, and what is the change of state, and what a process is. It is a change of state of a system from one to another. From one equilibrium state to another equilibrium state, when the system moves or changes, it is called a process. Right? Now, what is the importance of quasi-static process in thermodynamics is it is very easy to analyze. We will see what quasi-static process in detail. So quasi-static process is very easy to analyze. If you assume that a process is quasi-static, means it will be quite helpful for us to analyze the problem easily. Okay. On the other hand, if it is a non-quasi-static process, we may have to put forth a lot of other assumptions, or a deep rooted analysis might be required to study and analyze the problem. So, a process in which all the intermediate states, so when a system changes from one state point to another state point, it is not immediate. The system may have to pass through a number of numerous intermediate states. I will show you a property chart in which intermediate states are marked. So, a process in which all the intermediate states of the system passed through are in equilibrium with each other or with the surroundings, that is called a quasi-equilibrium or quasi-static process. A process in which not all the intermediate states are in equilibrium, that is called a non-quasi-equilibrium process. That is a non-quasi-equilibrium or non-quasi-static process. So how can we achieve an equilibrium process or quasi-equilibrium process? The process should take place pretty slowly. In an infinitesimally slow manner, the system should proceed from one state to other state. The process should take place very slowly, then only the process will be quasi-equilibrium process. If the system is moving from one state to another suddenly, for example, a piston cylinder device, if a pretty high pressure is applying on the top of the piston, quickly the compression process will not be quasi-static at all, because the molecules immediate to the cylinder head, the piston head, will not get enough time to relocate. It will be randomly oriented, it will be moving randomly, so that the process will not be, the intermediate states will not be in equilibrium, therefore it would be a non-quasi equilibrium process. On the other hand, if you apply the pressure slowly, we can have a quasi-equilibrium process. We will see the examples for quasi-equilibrium as well as non-quasi equilibrium. So here you can see a piston cylinder device. Inside the cylinder you have a gas initially at a temperature of P1, volume T1, temperature, pressure P1 and volume V1. Okay, and correspondingly the state 1 is marked here with a pressure P1 and volume V1. Okay, this is a property diagram. This is called a property diagram. On the y-axis one property will be marked, and on the x-axis another property will be marked, and the change of state will be marked like this using a curve. Fine. So initially the system is at a pressure of P1 and a volume of P1. Now what we are going to do is we are going to remove the weights placed on the top of the piston one by one. A number of weights, you can see a number of smaller weights are placed on the top of the piston. Okay, a number of weights are placed. Fine. So now we are removing the first weight, smaller weight, so that the system will be moving from this state to this state. The second intermediate state, that is equilibrium, another equilibrium state. Fine. The system will retain its equilibrium at another point, this point where the pressure will be some intermediate pressure, P11 or PV11, something like that. Fine. Now again, if you remove the next weight, so what I'm trying to say is, when you remove the weight one by one slowly, the gas molecules will get sufficient time to redistribute themselves properly within the cylinder. Fine. Now next weight will be removed so that the system will be reached onto the next equilibrium condition, intermediate point. So likewise, all these smaller weights will be removed until the piston reaches the stops. Stops are provided here. The final state where the pressure is P2 and volume is V2. So one by one these weights are removed so that the system sorry, changes its state from state 1 to state 2 by removing the weights one by one, so that a curve like this is obtained, a continuous curve in which intermediate states are in equilibrium. Fine. Now let us analyze the same problem again, but here the difference is, instead of smaller weights, a large weight added together, the smaller weight equal to the sum of the individual weights is placed here. A weight weighing W is placed on top of the piston, and we are going to remove this weight at a time altogether. This W is equal to the sum of small w1, w2, w3, etc. Fine. Now we are going to remove this W at a time altogether, so that the system will change its state from 1 to 2 immediately. Fine. From P1 V1 to P2 V2, it will be changing suddenly, and the piston will strike onto the stops with an impact. Okay. Suddenly this piston will be moving from this position to these stops where the stops are provided. Still we are able to get a curve like this. We don't know exactly this curve is right or not. It can be like this or like this. We don't know the intermediate states at all here. The problem here is, when we are removing this weight as a whole, the gas molecules within the cylinder will not get sufficient time to redistribute themselves properly. So the orientation of the gas molecules will be random. Okay, they may not be able to relocate in an order. Fine. So that intermediate states will not be in equilibrium, or intermediate states will not be equilibrium states. So this is a non-quasi equilibrium process or non-quasi static process. So in thermodynamics, we usually assume all the processes are quasi equilibrium or quasi static process for the ease of analysis. I hope that is clear. If you have any clarification required, any doubts, please use the comment section below, and please give your valuable feedbacks and comments, and subscribe to the channel to get regular updates, and share with your friends those who are learning the subject. Thank you for watching. Have a good day.